Okay, so welcome back, guys. Let's start talking about the solution of the homework 3. Okay, the first question was, I guess, about what was it about? About interpolative decomposition. I think I gave you this matrix. And first of all, I asked you to write it in the form A equals by z, right? A equals b by z. Am I right, guys? Yeah. So I wrote it first of all in. Yes, go ahead, please, if you have anything to say.
No, I was answering you for that.
Hello, sir. Okay, so so the first step or sub-step is to write it using the CR, the regular CR factorization we've seen at the beginning of the semester. Okay, as you can see here, we have column. In fact, column 4 is twice as column 1, right? And column 3 is twice as column 2. So basically, you can just use column 1 and column 2 to write the CR factorization. Now, let's assume for a while that R is equal to Z, okay? And C is equal to YB, okay? This C is equal to YB. Okay, then this is what I'm going to write. First of all, let me take this B. The initial B I'm going to take is 213, this guy, okay? And so the corresponding Y, as we've seen in the slides, will contain the I R part, and then C and X M minus R times B minus 1, okay? So now I need to determine what is C M minus R and multiplied by B minus 1. Okay, of course, B minus 1 is here. It's 1 over 5, yani 1 over the determinant of B multiplied by 3 minus 1 minus 1, 2. Okay, so what is Cm minus R? In fact, this is the last row in C. Okay, because when you write M minus R, it means you removed the R part, the small r, the one with the rank of the matrix. So we removed B from it. Okay, in fact. Okay, so it's 2, 1, Cm minus R is 2, 1 multiplied by B minus 1. You get this beautiful 1 over 5, 5, 0. So basically it's 1, 0. Okay, so I'm going to place it where? In Y. So I just completed now the writing of Y. Okay, yes. So my target was to write C in terms of Y times B. So now I can check that Y times B gives me the same C I had before. Okay, so I'm just checking here that everything is fine. I got the right way to write YB. Okay, so this is the first step. Okay, now what I'm going to do, I'm going to use this rule to update B and pick the one with the largest determinant in absolute value. So I can check them all if you want. I can do just a simple enumeration. I go the hard way. I can go B12. What does it mean, B12? It means B12. It means I'm writing B11. It means, what did I mean here? B12. It means possibly the first one I've taken. B12. B13 is I'm taking column 1 and column 3. It means 2, 1, 2, 6. So it's for the choice of the column, as I'm defining. Okay? Sometimes I write nerdy things and I forget them, guys. So this is the choice of the column 1 and column 3. So I get 10. Okay, so I'm improving. B14, when I select column 1, column 4, I get 0. Now till I reach, for example, B34, I get minus 20, and you can even go through the whole matrix. In fact, this is the best you can do. There is a plus 20, but it's not necessary, in fact. So B3 is the submatrix with the largest determinant, 20, an absolute value. Well, you might also choose 6, 2, 2, 4 when you pick the one which is just underneath this one, as you see it here. But it's not necessary here. Okay, so now B is updated. It's B max 2462. So I need to compute first of all its inverse, which is -1/20 times 2 minus 4 minus 62, and the corresponding Cm minus R. What is it now? It's 24. Why? Because the C now for you is 2462, and the last part, which is 24. Got it, guys? Yeah. So it's 24. C minus M, C index M minus R. You remove the upper part which corresponds to the B max. So you're left with 24. And if you multiply it by the B inverse, so you compute it, you get again 10. Okay? So I just update now that part. Okay. Now I'll move on to page 2. We now need to update what? Now to update Z. Okay? I have the B, I need to update Z. So in the Z old, in fact, the N minus R was 1001. And I need to update it in a way that the B old times the Z old equals that 2113. Okay? To do that, what do I need to do? I need to write this system. Where in fact, the new B, in fact, the new B here, okay, times the new Z equals the old B times the old Z. So when you multiply by the B inverse, you'll find the Z, as you've seen in the slides and the textbook also. You get the right way to fill the missing columns in the Z new. Okay, so if you do the operation, so I just multiplied the B inverse, the new B inverse, by this part, which was taken on the old Z, 2113. And I've got 0, half, half, 0. So I have to play them here, where in the columns 1 and 2 in Z, of course. That part is just I, as you've seen in the definition. So let us verify now that if everything is all right. So after I found this, I need to verify that YBZ gives me back A. Okay, so this is my new Y as updated. Okay, I just played that last part I computed. This is the new B max, and this is the new Z. I do the operation. I get here, I generate 262424, which is basically the new C, one with columns 3 and 4. And here I multiply, I get exactly. Okay, so as you can see, all entries in Y and Z. Okay, in Y and Z, where is Y? Y is here, and Z is here. As you can see, are an absolute value less than 1, which means I answered perfectly the question. Got it, guys? I do satisfy the condition. Okay?
Yes.
So, okay, got it? Okay. Now, for the B part in this question, question 1, I asked something else, which is to use the mixing matrix. So write, in fact, A as CMR. Okay? Well, since I left you can take any choice, I said, of CR, but the corresponding M should correspond to the formula you just said. So I played wisely as a regular student, someone who understands what we are talking about. Okay? I've just picked the same C and R we got before, okay? Right? Okay? So if you do it the right way, you can get M which is equal to 1. You can verify it. Okay? So I've just used the same answer here as in A to save time. You can easily verify it with MATLAB or Python, and you can use a different CNR. And for sure, I've seen some of you already sending me the answers, and they already used a different answer. I think it's just a matter of computation. Okay. You have this formula in the textbook and the slides, right? I mean that part. So that part is the easy part. Okay, so let me move to question 2. In question 2, it's a matter of splitting the system of equations, and we've talked about this question before. Here I've shown you that I went the wrong way. Okay, first of all, so I've taken the diagonal part, which is in A, which is 3, 3, 3, and I put it in S. I computed the S inverse, I compared it to the corresponding t. I multiplied S inverse by t. I found not too bad a norm for S minus 1 S inverse times t. Well, and I said to myself, let me iterate. Okay, if I iterate here, now what happens? I'm just computing now x1, which is S inverse t times x0 plus S inverse p. So I get 0, 0. If you get 0, 0, you won't recover. Okay? So this choice will just make you cycle between 0, 0 and 0, 1. You can try it for the Python code. It would make you just cycle. Okay? So now I'm just perturbating, as I said, or you can just enlarge the diagonal. Some of you just took 4, 4, 4 in the diagonal, everything to 0, else to 0. Some they did perturbation. I'm just adding this part in my matrix, which is 2. So I've borrowed this 2 from where? From here. So the impact on t is just small. Okay. So this is the corresponding S inverse computed. Okay. And I did the first iteration. This is t updated, and this inverse times S inverse times t. I did it manually, went the hard way, as you've seen it. And this is the norm of S inverse times t. And finally, this is the first x1 I get when I do the first iteration. Okay? Of course, I already made the Python code available, so you can just update the S here and the A, and you can write it. And you can see that the final answer should get after 10 iterations. In my case, some of you, they got it just in the first or second iteration, which is much faster. I got the answer, which is half, half, half. Okay? I think it's clear for everyone. Am I right? Any question on this, guys? Let's move forward then. Okay. So question 4. So here you see I skipped question 3 because I'm talking about the written questions here. If I want me to detail the lang source algorithm, it will take another 1 hour at least. So I skipped to question 4. I will update I'll just update the Python code. Okay. So now question 4. What is it about? It's about computing what we call the pseudo inverse. And as you can see here, because some of you they went the wrong way, I made it intentionally such that rule 1 doesn't work. So you have to use rule 2 here. What does it mean here? The columns here of A are not dependent. You can check that. In fact, column 2 is equal to half of column 1 plus column 3. Yeah, it's easy to know. So you cannot apply rule 1. And those who applied rule 1, they found something weird. So you need to apply rule 2. And you can see that this matrix has independent rows. There is no k. Here I'm just explaining. There is no k such that k R1 equals k equals R2. So I'm just using the formula. So A plus the pseudo inverse is AT times the inverse of AAT. So this is A here, and this is here I'm trying to compute the inverse of AAT. So I'm just doing the product first. I get 5, 1, 1, 5. And inverting it, I get 1 over 24 times 5 minus 1, 1, 5 here. And finally, what else? I'm just doing the operation. I find something here in fraction. Okay. Note here, guys, I want you to work manually. Okay. Not use MATLAB to compute. I wanted you to find it this way. Okay. You can verify that your answer is right with MATLAB, but I wanted the fractions. Minus 1 over 12, 5 over 12, 2 over 12, 2 over 12, 5 over 12, minus 1 over 12. Okay? Got it? So I'm just verifying again as a good student, which I am. I'm just doing the operation that A plus should give me I here. I'm multiplying A by A plus, I get the I2. I deal with the right size 2. Okay? Now, I'm using this pseudo inverse to solve this unsolvable system, or in fact, this system, which is not unsolvable basically, but it was just a system of 3 variables and 2 conditions. Okay, so B here for me, BT is 3, 3. So X plus is A plus B. I'm just multiplying A plus by B, get 1, 1, 1. Okay. Of course, this is a particular solution of the system in general. Okay, but this is a solution which gives me the lowest norm in this solution space. Okay, so for the system AX equals B, in fact, the general form of the solution is this one. Okay, and you can see this is the solution when T equals 1. In general, basic linear algebra, if you use a Gaussian elimination here or Gauss-Jordan elimination, you get the solution which has the parameterized form T3 minus 2T, T, or whatever you can write it. In fact, this is the intersection in geometry. This is the intersection of two planes. So it is, but here you have the system of equations or the parameterized equations of a line, as you've seen it in calculus 3. So this point, in fact, the 1, 1, 1 is just a particular point of it. It's the one that minimizes the norm of x. Okay. So how to show now? I've seen some of you, they didn't show that this is the least square solution, because now when I take the general form of the solution, I can compute its norm, okay, and I can even try to minimize it. So if I do least square minimization here, this is the objective function. Now instead of minimizing the square root, I can remove the square root. I can optimize t squared plus 3 minus 2t squared plus t squared. Are you following me, guys? Do you understand what I'm saying?
Yes.
Yes, hopefully. Yeah? So, because I need to show that 1, 1, 1 is the least square solution. Okay? So, that was part B in the question, I guess. So, this is the norm. I just need to do basic math 101 stuff here. Just differentiate with respect to t. I get 12t minus 2. So the t equals 1, which means that x plus solution is the one that minimizes the norm of the solution. Okay? Got it? Is it clear for everyone, guys? Okay? Now I move to C. Okay, let's move to C. So someone wrote something. Can you just record? Yes, I'm recording, guys. Okay, so in question C, what did I ask for? I said, can you use the SVD to show how the SVD decomposition to relate the SVD decomposition of A plus to A, or vice versa. So, in fact, what you can do here, you can use here, I made it very smooth. I said, even when I talked about the homework, I said you can use MATLAB if you wish, just to show that things work. Okay? So, in fact, the A plus decomposition in SVD gives you these matrices. This is the V, and this is the sigma plus. It should be 3 by 2, guys. Huh? This is UT. And you can check now, once you've got the SVDs of the A plus, you can check them once you switch them. So this guy becomes the UT, and this guy becomes the V. And here, the sigma plus, you take just its transpose, and you can see that if you do the computation, you can obtain A. Got it? So you can go both ways. From the SVD decomposition of A, you can find the one of A plus and backwards. And you can even verify that sigma plus times sigma is the identity of size 2, and sigma times sigma plus is the entity of size 3. Now, how to do that? In MATLAB, you can use the P inverse version, which is the pseudo inverse version, if you want to get the sigma. Just to check it. I mean, but in fact, it's easy. It's easy stuff. You can even just from first sight, you can guess what is sigma plus. Okay, so that was about question 4C. Right? Now, Gram-Schmidt. I love this question because this is maybe the first time we're doing it by hand. Okay, we did one example in the lecture. As I told you, look, the solution we're going to have here, because a 3 by 3 is not exactly going to get with the MATLAB. So we've taken the MATLAB solution because it used the permutation matrix, which was A P equals QR. Okay, that one works perfectly. This one in the homework works perfectly. I have a simple 2 by 2 matrix, 4, 2, 1, 3. I'm just following the algorithm. The algorithm says what? Take Q1, which is A1 over norm of A1. What is A1? The first column in A, okay? Which has a norm equal to root of 17. I divide by root of 17, I get these numbers. Okay. Now, this capital A2 is, in fact, the second column in A, which is here, minus what? The formula said in the algorithm, it should be A2 transpose times Q1, you just obtained, all times Q1. I'm just doing the math here. It's 2, 3. 2, 3 minus 2, 3, because now it becomes a transpose, it is a small row, multiplied by 4, 1, all multiplied by 4, 1, and just divided by root of 17, so I put the 17 downstairs, okay? So I put now, when I get the operation here, 2, 3 times 4, 1, I get the 11. 11 over 13 times 4, 1. So I do the math, I get these beautiful numbers, you get minus 10 over 17 and 40 over 17. Now, I can update Q2, it's going to be equal to A2 over its norm, so I get this beautiful, okay? You can write it in fractions if you wish. In fact, you can even see that there is a simplification because the 17 gets upstairs, it is divided by something, okay? So this is the Q for me. Finally, I can place the Q and Q2 in this form. This should have been removed, it should be this way, okay? So this is to me Q. I can write it also in fractional form for those who wanted to see it in fractional form. That's Q2, okay? Minus 1 over 16, 4 over 17. So, and that was the Q1, which is 4 over 17, 1 over 17. So when I now, why do I need to do this? Because I wanted to show it by hand that I can have a way to get R. And we said that R is what? Is QT times A. So once you got Q, you can just use the transpose, multiply it by A, and you get to the R. So if Q is this one, QT is 1 over 17, 4, 1 minus 1, 4. Multiplied by A, I'm doing here the math. You can get in this small part 17, 11, 0, 10. So this is R. Okay? 17, 11, 0, 10, all divided by root of 17. At the end of the day, you can just here verify. So now here I'm verifying what? As I said in the question, verify that RTR equals ATA. Here I'm doing the math, multiplication. RTR gives you 17, 11, 11, 3. I'm doing it by hand, all by hand. Huh? And ATA gives you 17, 11, 11, 13. If you want to get to be relaxed, you can do it first of all by MATLAB, which I did, honestly. And then I checked by hand that it works. Okay? So just wanted to save time, not write a wrong solution. I verified that my solution works by hand, and then I wrote my solution. I verified my solution with MATLAB, and then I wrote it by hand. Okay, so we have the detail, and of course, the second part was to verify that. What was it about? To verify that R inverse times QT is equal to what, guys? Is equal to A inverse. Yes. I get this, which is exactly the inverse of A. Is it okay, guys? A lot of math, and I love math. I'm sure you do. Okay, now can I move to question 6, guys? Yes, Firas, you have something to say? Nothing to say. Okay, so ضفتوا شباب كينكم. Did I knock you out? So I'm by myself. Everyone left.
Yeah, I didn't either way.
Okay. So let me finish. Okay. والله شيء عجيب. ايش يا عبد العزيز؟ شيء عجيب ايش يعني؟ What do you mean? Translate for our YouTube viewers. This is math. Math is kind of magic, brother. And I get, if the guys give me 15 minutes, I'll show you more crazy stuff today with my lecture. Okay. Right, let me finish with this question, okay, please. Question 6. Because question 7 is about the Kalman filter, and I can easily do Excel. Already did that. Right? The discussion part we'll talk about it later because we need to talk about it for the project. Okay? So question 6, it's about, well, it's easy, huh? But it requires a lot of computation. So first of all, there is a shortcut to solve question 6, by the way. I'll show you the shortcut.
So in question 6, what did I do? I have M, well, the same matrix A, which is 4, 2, 1, 3, and this is the beautiful formula we have to update the M inverse. Okay, so the first part is to get M equals A minus UTV. So this is U. So I'm doing the math. So the new M is 3102. You can easily get the inverse. Okay. So I'm just checking now that inverse I can easily get with basic linear algebra stuff. Is exactly the one I get with the updating formula. So I'm using the updating formula, placing A inverse plus A inverse times UT times 1. Here, why should I use 1 at I? Because it's a 1, 1. It's a rank 1 perturbation. Okay? So 1 minus 1, 1, which is U, times V, sorry, this is V, times A inverse, times UT, all times V times A inverse. Okay, I do the math, I get exactly the same answer. So this is the M inverse I got here. So that was for the, I've given you the details, okay, of my computation. So this works fine. And the last part was the same thing, but now using matrices. So basically it's a rank 2 perturbation. This is the new M, should be 3122. So I can easily update the M inverse and check that the one with the computation works fine. You should get something like this. I did some mistakes. It took me like 5 to 15 minutes to figure out what was my computation mistake. So I separated here. I called this guy, I called it L. This part, all this part, I called it L, till the part. And I took L here to update it, okay, to compute it. I finally found L and added it to inverse, that part. So just to give you a way to understand that thing. So this is the L, and I added it to A inverse. I got exactly this, okay, which is exactly the M inverse I had before. Okay, so this is, guys, for the solution of the homework 3. Thank you very much.